from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about Gaia Knows Best, and if I have time, what's that smell, and galactic facial recognition, and of course, taking listener questions about all things in the universe, because that's what this show is about. We record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about the nature of hubris. But first, the news. I'm not hearing myself. Do I sound good to you guys? There I am. Now I sound great. I mean, I always sounded great, but I just couldn't hear my own voice. What's the point? Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI, and for the next half hour, your agent of the stars. We've got an exciting show for you today on Space Radio where we talk about all things in the universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. So call 888-581-0708 to join the conversation. You can also follow along on our live streams on YouTube and Twitch. Go to spaceradioshow.com for those links. And hello to the Space Cadets tuning into the live stream from Austin, Texas, Garden Grove, California, Kohima, Nagaland, India, Norg, Netherlands, and Bakshi Petrovac, Serbia, and Austin, Texas. Welcome, Space Cadets from around the world. Send your questions there. We'll get them on the show. You can also follow me directly on Twitter, Facebook, and Instagram. My name is Paul Matt Sutter. Seriously, folks, I've prepped 10 minutes of show material tops, so get those calls in. Before I start taking questions, I want to share some juicy astronomy news with you today. And the biggest thing that came out just yesterday, Gaia. The most exciting astronomy mission that you've never heard of. You know, James Webb gets all the glory. Kepler gets all the glory. All the big news about Hubble, blah, blah, blah. But here is a mission, a major collaboration with a space satellite doing some fundamental astronomy. Folks, astronomy is all about the data. It's all about precise measurements of the night sky, of the positions and speeds and temperatures and spectra of stars and solar system objects and nebula and galaxies. This is the very basic core of astronomy. What started the Copernican revolution to get us on our modern path to, all of science? It was taking measurements of the solar system. What got us into spectroscopy and understanding the nature of elements and the movement of forces and fields and particles in the universe? It was taking astronomical data of the stars. What got us to unlocking the size and expansion of the whole entire universe? It was measuring the positions and velocities of galaxies. This is a fine tradition in astronomy, folks, and Gaia is continuing that tradition. They have precise measurements, distances to over 1 billion stars. That's right, billion with a B, classic Sagan billion, right up there. Now, to give you a sense, the Milky Way galaxy, our home galaxy, has between 3 and 500 billion stars, so we've mapped at best 0.3% of all the stars in the Milky Way. So we've still got a lot to go, but hey, 1 billion is 1 billion. I'll take it. And there's so many questions in astronomy, so many questions about the nature of stars, about the life cycles of stars, about the relationship between stars and nebula, how they live, how they die, how they're born. All that depend on knowing the precise positions of stars. Because if you just look at a bright spot in the galaxy, you're like, hey, look, that's an interesting star. Now, am I looking at a normal size brightness star that is relatively close, like a neighbor? Or am I looking at a really bright star that's really far away? Without any other information, without any other context, you can't tell. And so if you're just looking at a point of light, you don't really, until you know its distance, you don't really know its nature. You don't really know its character. Once you pin down its distance very accurately, then you can say, that's a bright star, that's a dim star, that's a medium star, another bright one, another bright, etc., etc. And then that unlocks, okay, now I know the star's position, I know its spectrum, I know its temperature, I know its luminosity, I know all these basic astronomical facts of each star, and you can put together a better picture. It's like trying to do a census without even knowing, like, the age of people. Like, you're going to get where they live, all right, you're going to get their income, but you're not going to get their age. That feels like a major piece of information that you need for a proper census. Now we're getting that kind of information for a billion stars. So take that, James Webb Space Telescope. That'll probably not even launch in my lifetime. Gaia is here and producing juicy, juicy data. So it's not like there's any groundbreaking results coming out of the first release. This is a public data release of their mission. But we have this massive database that is going to be mined for decades. Remember to call 888-581-0708 to join the conversation or catch me on the live streams on Facebook. No, not Facebook. We don't do that one anymore. We do it on YouTube and we do it on Twitch. Let's take some questions. There was a good question in the comments. Yeah. All right. What was it about? Yeah, up here. Sorry, I gotta scroll back. Okay. We've got a great question here on the YouTube live stream from 9 Chimera asking, do the farthest away galaxies, which are the galaxies, earliest in the universe, still exist? And if not, does the universe as it stands contain less galaxies than the billions or trillions estimated? So great question. Lots of interrelated topics here in this question. Getting back to this fundamental astronomy, what are the demographics of our universe? What kinds of galaxies are made when and how many? So current estimates, and this is, you're going to laugh at the result of this because I'm really taking the word estimate seriously. Current estimates pin the total number of galaxies in our observable universe at somewhere between 500 billion to 2 trillion. All right, so that's quite a margin of error because it's hard because most galaxies are small and dim and hard to spot, so we don't have a complete mapping of them. So it's hard to get that final count. So it's somewhere around 1 trillion plus or minus, 1 trillion. And the question is, as we look out further and further into the universe, we're looking further back in time. That's because light takes time. It's super fast, but on cosmological scales, it's kind of slow. And so it takes time. So we're not seeing a picture of a star or a galaxy or something distant as it is right now, like in this moment. It's as it was in the past. It's like taking a picture, like a Polaroid, and then sending it to someone in the mail, and they get the picture and they're like, wow, that's what so-and-so looks like. Isn't that great? Well, that's not what they look like now in the moment, the instant of you opening up the postcard, opening up the letter. It's what they look like when they sent it a few days ago or a week ago. So that's our picture of the universe. And the more distant thing you're looking at, the older it is, the earlier it appeared in the universe, the younger the universe was when that light was emitted. So the question is, back in the day, the good old days, like 10 billion years ago, was the universe having the same kind of population of galaxies as it does today? Are the demographics the same? And the answer is no. And the answer is no. And this is one of the primary pieces of evidence we have that the Big Bang model of the universe, that we live in an evolving, changing, dynamic, expanding, growing universe, is on the right path because the universe of yesterday looks very, very different than the universe of today. There were more galaxies back in the day, and there were smaller galaxies, and they were actively merging because the universe was smaller and all that stuff was crammed in close to each other, so they kept running into each other. And so when we look back in time, the large scale structure of the universe looks different. Galaxies are merging more often, they're lighting up. We're seeing what we call active galactic nuclei more frequently in the early universe because they're triggered, we think, from the merging of galaxies. The present day universe is relatively mature, relatively calm, relatively, middle aged. It's got a job and a mortgage, maybe a couple kids. It's settled down, has a hobby on the side, but nothing too crazy. That's our present day universe. The young universe was very, very different. And because of all that merging, because of all the high density gas we had way back then, our universe had more stars. Our universe was producing more stars billions of years ago than it is today. In fact, the peak of star formation in our universe happened 9 billion years ago. 9 billion years ago, the universe was producing more stars per unit mass per year than it is today. Our Milky Way galaxy today produces about one new star a year, on average. Peak star formation way back in the day was about 10 times higher, and it's been on a sliding downhill slope ever since. So our present day universe, when we contrast it to the early universe, was very different. Our early universe was more full of stars, had more smaller galaxies, than these galaxies merged together to become larger objects. And nowadays, there's more space between the galaxies. The galaxies have settled down. They're not producing as stars as frenetically as they used to. It's just a different game today. And in the future, this trend will continue. There'll be fewer and fewer galaxies. Galaxies themselves will wind down star formation. They'll slowly become dimmer and darker. Galaxies themselves, instead of merging and agglomerating, will actually start to rip apart from each other. This is due to dark energy, which is a different segment. I won't get into that too much. And slowly over time, and I'm talking like 100 trillion years, so no rush, don't hold your breath. Over the course of 100 trillion years, our universe will slowly get dimmer and cooler. And that's kind of depressing, but at least we don't have to worry about it for a very, very long time. Excellent question, 9 Chimera on the YouTube live stream, one of the lovely, lovely space cadets. And you can join the conversation if you want to call 888-581-0708. And I gotta tell you, this show is brought to you by you. Our favorite sponsor is, yes, you, patreon.com/PM Sutter to learn how you can support the show. You are making this show happen. You are keeping it on the air. Dan Michalko said, if you don't get one more Patreon subscriber, then this show is actually, he's going to start hosting the show himself. He never said that, and I hope he doesn't listen to that part. Dan, you're a wonderful person. Greg, you're pretty nice too. I'll see you after the break. All right. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. I've got another live stream question ready to go and a little bit of news. But remember, you can join the conversation by calling 888-581-0708 or by following the live streams on YouTube and Twitch. Check out spaceradioshow.com for all the amazing links. Also, by the way, we archive the show as a podcast where there's like music and stuff, and Greg does a really good job of editing it. It lives on there too, so you can subscribe. You can time shift this show to your heart's content. And well, I was trying to come up, as I was saying all that, I was trying to come up with a wonderful segue, good transition into this news topic. I ain't got one, so I'm just going to blurt it out. Uranus smells like farts. And I never realized, is this like a middle schooler's dream fantasy astronomy news story? That the planet Uranus. We'll try to bring it back to the original Greek here. We're going to call it Uranus for the rest of the episode. There's hydrogen sulfide in the atmosphere of Uranus, and if you've never smelled hydrogen sulfide, that's the rotten eggs. That's the, trapped in an elevator, bad day kind of smell. The smell you never want to encounter. I mean, Greg, I get a whiff of it when I walk by Greg in the hallways, but it's like that. So if you ever want to experience that, come take a tour of WCBE radio. And yeah, so the planet Uranus is, hydrogen, it's helium, there's nitrogen, there's a bunch of ices in the core. In fact, we call Uranus and Neptune ice giants now, if you haven't been keeping up with the terminology here. The two outermost large planets of our solar system are not considered gas giants. They are considered ice giants because they're not primarily hydrogen helium. They had different formation mechanisms. They have different compositions than Jupiter and Saturn, so they're ice giants. Maybe we should call them fart giants. I don't know. I'm just tossing that out there. I'm not a voting member of the International Astronomical Union. If I was, they probably wouldn't ask me because that's the answer they would get. So yeah, there's been some recent news where there's not a lot. There's not a lot of hydrogen sulfide in the atmosphere. I want to say, I'm trying to pull up, no, here it is. Somewhere between, so there's this general atmosphere, and then there are clouds of hydrogen sulfide and ammonia. I should say ammonia is the primary composition of the atmosphere of Uranus. And then there are clouds of hydrogen sulfide, and the clouds of hydrogen sulfide have 8.8 parts per million hydrogen sulfide. And I don't know, and that's 5 times more than Jupiter and Saturn, which is a pretty good deal. I don't know if that's enough to smell. Maybe. I don't know what level of concentration of hydrogen sulfide you need in order to trigger your smell and your ill reflex. But there it is. There it is. Uranus smells like farts. And who would have guessed? Never would have figured that one out if you had to just ask a random 6th grader. It turns out they knew all along. Now I got a question here on the live stream from Varge Store Anderson, who's asking, do you believe that Betelgeuse will go supernova in our lifetime? You saw a documentary about that, but they didn't really answer the question. Yeah, they didn't answer the question because they didn't know. And Betelgeuse, of course, the iconic movie character, is named after a star in our galaxy that is of Arabic origins, Betelgeuse or Betelgeuse. There are a few different ways of anglicizing that Arabic word. It means, in some translations, it means armpit. In others, which is hilarious, in other translations, it means shoulder. It's the shoulder of Orion. If you look in the constellation Orion, Orion has a big red shoulder. You're looking at the star Betelgeuse. Now, Betelgeuse is a gigantic star. I mean, it is a big boy. And if you were to plop it into our own solar system, it would stretch to something like the orbit of Jupiter, or at least the asteroid belt. It's large. I don't remember the exact number. It's just large. And you put it in our solar system, and it totally dwarfs anything, even including our sun. And yes, I did say Betelgeuse 3 times, so go ahead. I'm not scared. Now, this star is ready to blow. This star, Betelgeuse, is going to go supernova any day now. And I'm using the word day here in the astronomical sense, which means sometime in the next million years. This is a star that is towards the end of its life, a massive star towards the end of its life, where it's fusing higher elements, it's fusing nitrogen and oxygen and carbon in its core. It's going to build up to magnesium eventually, and at some point, it's going to go boom, because it's going to fuse iron and nickel in its core. It won't be able to fuse that any higher elements and extract energy from it. So that iron core is going to collapse in on itself, become a neutron star. It's going to bounce off that neutron star and kaboom. In fact, it may have already happened. It may have already happened, and we just don't know about it yet. Remember what I said about on the top of the show where it takes time for light to travel across the universe? Well, if Betelgeuse is, 500-600 light years away, something like that, It could have gone off at any point in the past 500 or 600 years, and the light just hasn't reached us yet. So we're looking at a fossil, we're looking at a relic of something that could have already detonated centuries ago. When it goes, or if it's already gone, it's not going to be a danger to Earth. It's not going to irradiate us. It's going to be a very, very pretty light show. It's going to go boom, and it's going to light up intensely. It's going to light up probably, most likely, it's going to be visible during the day. No joke about this. No joke about this. It will be so bright that you'll be able to see it in the middle of the day. The last time this happened was about 500 years ago when a supernova went off in our own galaxy, and we were able to see it during the day. It's relatively rare. We're about due for it. Betelgeuse is a good candidate. Has Betelgeuse already gone off? Will it go off in our lifetimes? We honestly don't know, because we're talking about timescales that are in the order of 1,000,000 years. So it's hard to make, is this going to happen Wednesday or Thursday kind of thing predictions. We can say, oh yeah, it will happen probably this geologic age. That's what we're talking about in astronomy, with those kinds of timescales, with those kinds of being able to make predictions. So Betelgeuse, we may kiss it goodbye in our own lifetimes. I wouldn't hold my breath, though, because this is an astronomy thing, and astronomy things take, they don't really pay attention to human timescales here. But there you go. And would it be brighter than the daytime noon? Oh, got a question from Tom Van Scotter on the live stream. Not quite, not quite. It won't be brighter than the daytime moon. It will be brighter than, most likely brighter than Venus and Mercury. Not brighter than the sun, because that's kind of challenging. But it will be visible during the day, which just blows my mind. That is something I want to see. Can I, talk to people who are in charge of this? I would like to see a supernova during the day in my lifetime. I think that would just be absolutely mind-blowing. And that'd be fun to talk about and look at and study and learn about the nature of our universe. Thank you to all the Space Cadets on the live stream for those amazing questions. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, and I want to talk about the Silurian hypothesis. Now, this is a paper that came out earlier this week, and if you've been paying attention, my live streams on Twitch or my appearances on Weekly Space Hangout or anything like that, I initially had an incredibly strong reaction, negative reaction to this paper. And thankfully, especially thanks to my Weekly Space Hangout compatriots, my colleagues, that I mellowed out. I still have some negative views of this paper, but you know what? I shouldn't have gone off the handle so quickly. I should have swallowed my immediate negative reaction and just dug a little bit deeper to see what they're really going for. So here's the deal. It's a paper offering a hypothesis. If there was any intelligent industrial civilization on the Earth before humans evolved, would we see it? Would we see it, especially in the geologic record? Like if we look at our effects on climate change, of how we're altering the Earth's climate, how we're doing all sorts of landscaping, how we're doing, we're just doing stuff on the Earth. If you gave that, 10 million years, 100 million years, 1 billion years, would there be any evidence left that another advanced technological society that had a passion for paleontology would go back and find? And my immediate initial negative reaction to the paper was, hey, we kind of have this thing called the fossil record. And the fossil record is very, very clear that there were no advanced, intelligent, technological species in the past. And the paper kind of sidesteps it, and it didn't sidestep in a way that I would honestly prefer, but I didn't write the paper, where it was said okay, let's ignore the fossil record for the purposes of a fun thought experiment, because this teaches us about the detectability of life in some way. Instead, it took a tack of, yeah, there's the fossil record, but it's incomplete, so we're going to continue with this hypothesis. I didn't like that because I felt like they could have talked to like any paleontologist in the world and got set straight. And then if they had recast the problem as a fun thought experiment to think about our human impacts, to think about how we go about detecting intelligent civilizations in the galaxy. Spoiler alert, we're basically not going to detect any intelligent species in the galaxies, but that's another show. Feel free to call in and ask. And so my initial reaction was like, hey guys, what about the fossil record? Why are you ignoring this? And then that spoiled my entire view of the paper. And then thankfully I had my weekly space hangout friends, colleagues, I'll call them friends, that took this, that elevated the discussion into this interesting thought experiment. The short answer is basically we wouldn't be able to find evidence of a intelligent technological species in the geologic record. That, yes, we're doing disastrous things to the planet that we need to address, but it's relatively short-term stuff. Give the Earth like 100 million years, and it's not really going to remember us. So, I don't know. Sleep well tonight. I don't know what the lesson is from that, but I got a lesson out of it, and I hope you did too. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing And You Don't Smell Bad at All, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join me on the air. You can also follow the live streams on YouTube and Twitch, or follow me on any social media channel at Paul Matt Sutter. Visit spaceradioshow.com for all those links. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Thanks for watching, guys. It's a shame no one called in because we have a fancy new call-in system that's way less laggy than it was before. There used to be this, seriously, 5-second delay between me saying something and the caller hearing it. And we played some games, we got some gear, and it's a lot faster now, but no one called in. But that's all right.
I think we lost momentum past 2 weeks.
Yeah, it's because we went on hiatus for a couple weeks, and I think that is... So Greg's in here, he's talking to me, I'm not just talking to myself. We need the show every week to build a momentum, to get people, remind people that they can call in, that they can count on that.
Because we had a bunch of callers that last live show.
3 weeks ago, we had tons of callers. We've had to kick people off because we didn't have time. And now it's... but we'll do it. We're back on track, except in a couple weeks I'm going to be out of town. But other than that, it's going to be great. Now, I need from you guys, the live streamers, the space cadets, I need one more thing. I need a title for the show. George Lancaster, I will call in next time. I believe you. I believe you. I've got you. Now, if I could only do something about the live stream lag, that'd be nice. Because I know you guys... you guys are 30 seconds behind what I say. Which is a little bit weird. We work around it. But the reason for that is we're simulcasting on YouTube and Twitch. And then that simulcast just introduces a little bit of a delay. So I believe you. But if you have a name for the show, toss it in. Uranus... Oh my gosh. Please, if you're going to make it a Uranus joke, you make it a classy Uranus joke. I mean, I'm all about being juvenile. Don't get me wrong. But I'd like it to be, just elevate the discussion just a little bit. Twitch EDU loves you, Paul. Well, I love Twitch EDU too. What is Twitch EDU? I don't even know what it is. I'm so ignorant of almost everything that happens on Twitch. To Betelgeuse or not to Betelgeuse. I like that, Tom. I like that, Tom. No intelligent life, 2000 AD. Yeah, George Lancaster, I know the chat lags. That's because the chat is being embedded. And it's, yeah, you can tell it's like 30 seconds behind. I think Twitch is a little bit faster. Twitch educational streamer, that's what a Twitch EDU is. That's me. I'm an educational. Uranus jokes never get old. Maybe I could just call it Uranus jokes never get old. I think that's going to be it. Uranus jokes never get old. I like that. I like that. Because it's not making Uranus joke. It's making a joke about Uranus jokes. It's like meta. It's like one level higher, which is where I like to sit. Kludgy Brains, if you want to know more about time dilation, tune in next week and we'll chat. We'll chat.
No. After you.
Thank you so much. So I got to go. I got to do a dance lesson. It's time for a dance lesson. So I will see you guys next week. We will be on next week. I promise. Although, don't take my promises seriously. Because that's just how it is. But thanks so much. I'll see you guys next week.